Okay, now we will see some sample problems from DFT. First question, let x of n is equal to del of n. Now del of n we know that is impulse sequence. Now how will find DFT of this particular x of n? It is found using this equation x of k is equal to sigma n equal to 0 to, that is summation n is 0 to n minus 1 x of n e raised to minus j 2 pi by n k n. Now this is now equal to sigma n equal to 0 to n minus 1. Instead of x of n you have del of n e raised to minus j 2 pi divided by n k n. Now n is not known in this equation, so you can write del of 0 e raised to minus j 2 pi by n k into 0 plus del of 1 e raised to minus j 2 pi by n k into 1 plus etc. plus what? Del of n minus 1 e raised to minus j 2 pi divided by n k n minus 1. Okay. Now we know for impulse sequence it is equal to 1 only at this 0th instant. For other than 0, at all instants value is equal to 0. So only del of 0 is equal to 1, del of 1, del of 2, etc. up to del of n minus 1, the value is equal to 0. So what will happen? The equation becomes 1. Del of 0, that is 1 into e raised to 0. So your answer is 1. So discrete Fourier transform of del of n is equal to 1. Now second question. X of n is equal to a raised to n. Now same way you can write the equation x of k is equal to summation n equal to 0 to n minus 1 a raised to n into e raised to minus j 2 pi divided by n k n. Now here also n is not known. So what we can do is summation n equal to 0 to n minus 1 and you take n as common to these two terms. So what will happen? 2 pi by n k all raised to n will come. Now this is similar to formula sigma n equal to 0 to n minus 1 a raised to n is equal to 1 minus a raised to n divided by 1 minus a for a not equal to 1 and equal to n for a equal to 1. So you compare, when you compare, this is in the place of a. So what will be the answer for sigma n equal to 0 to n minus 1, a e raised to minus j 2 pi by n k all raised to n. Answer will be 1 minus, instead of a, this term will come all raised to capital N divided by 1 minus 2 pi divided by n k. So this is the discrete Fourier transform of a raised to n is equal to a raised to n is equal to what? Uh, 1 minus a raised to n, you can write e raised to minus j 2 pi by n k. N and n will become, okay, so this n will become this is now this n is not there, okay, so 2 pi by n becomes 2 pi, Okay, into k you have divided by 1 minus a e raised to minus j 2 pi divided by n k. So DFT, discrete Fourier transform of a raised to n is 1 minus a raised to n e raised to minus j 2 pi k divided by 1 minus a e raised to minus j 2 pi by n k. And I will say one third example. Find the DFT of 4-point DFT of x of n is equal to sigma 1 minus 1 2 minus 2. Okay. Now for this one, what we can do is, you know that sequence length is equal to 4 here, and since it is 4-point, you can say n is equal to 4 and n is equal to L. So this exists. So now we will find one by one. X of n is equal to what? This is 1 minus 1 2 minus 2. So x of k is equal to, what is the equation? Sigma n equal to 0 to n minus 1 x of n e raised to minus j 2 pi divided by n k n. Okay, so this is equal to summation n equal to 0 to n minus 1 is 3 x of n e raised to minus j 2 pi by n k n. Now where k is varied from 0, 1, 2, 3 up to n minus 1 means up to 3. Now we'll find one by one first. First is x of 0. X of 0 is equal to sigma n equal to 0 to 3 x of n e raised to 0. Now the answer is x of 0 plus x of 1 plus x of 2 plus x of 3, right? Now what is x of 0? So x of 0 is equal to 1. X of 1, you can see it is minus 1. X of 2 is 2. X of 3 is minus 2. So 1 minus 1 plus 2 minus 2 is equal to 0. Now next is x of 1. X of 1 is summation n equal to 0 to 3 x of n e raised to minus j 2 pi by 4 into 1 into n. Okay. So what will happen? It will become sigma n equal to 0 to 3 x of n e raised to minus j pi by 2 n. So this is now x of 0 e raised to minus j pi by 2 into 0 plus x of 1 e raised to minus j pi by 2 plus x of 2 e raised to minus j 2 pi by 2 plus x of 3 e raised to minus j 3 pi by 2. What is the answer for this one? 1. Since it is x of 0 is 1. So 1 into, this is 1 again. So 1. Now x of 1 is minus 1. into e raised to minus j pi by 2 can be written as cos pi by 2 minus I sin pi by 2. So cos pi by 2 is 0 minus I will come. So this all this e raised to minus j pi by 2, e raised to minus j 2 pi by 2, e raised to minus j 3 pi by 2, everything can be written in this form, and then you can find the value. So now I will rub this. Instead of this one, I will write just the value. Okay. So this is minus 1 into, we'll be getting 0 minus j. Similarly, x of 2 is 2. This term will become minus 1 minus 0 minus 2. 0 plus j will be the value. So answer is equal to minus 1 minus j. Same way, you can find, now you have found out x of 0 and x of 1. Then you can find x of 2, which will be equal to sigma n equal to 0 to 3 x of n e raised to minus j. When k becomes 2, it becomes pi into n. Now the answer for this becomes 6. X of 3, it is equal to summation n equal to 0 to 3 x of n e raised to minus j 3 pi by 2 n. Okay, so for this you can substitute the values, and then you will be getting answer as minus 1 plus j. So a final answer DFT of this particular sequence x of k is equal to 0 minus 1 minus j 6 minus 1 plus j. This is the DFT of the sequence. Okay, thank you.